So here we are, the Coriolis force. Okay, so it appears in rotating fluid on time scales exceeding 1 day. Oh, what does that mean? What does that mean? For example, let me just throw something. Okay, I just throw something and let's see whether I can see the Coriolis force. Okay, I throw something. What can I throw? Let me see, the mouse, no book. Here, just my mobile phone. Okay, I take my mobile phone and just, I take my mobile phone and just throw it. Did you hear that? Okay. I couldn't see any Coriolis force. Okay, because I could see gravity. I mean, gravity, or it's actually relative gravity relative to the density of the ambient air. But I could see it was, my mobile phone was falling down, but along a straight path. So it's not the Coriolis force. Also, if you are having a bath and you get these bathtub, the bathtub eddies, or however they're called, these swirls up there, it's not the Coriolis force because the time scale is way too short. So what you need in order to see the Coriolis force is a process that lasts longer than a day. This is important. Okay? Like you have a very long pendulum, some weight hanging on a very long rope, let it swing back and forth on a time scale of longer than a day, and then you can see that the direction of that motion actually changes under the influence of the Coriolis. Okay? So the Coriolis force in the ocean is perpendicular to the direction of a current. So in the horizontal direction. And this is shown here in this little sketch. You look from above and you can express a current, a horizontal current, by a vector. A vector points into a certain direction and has a certain magnitude. And you can express it in terms of two components, and this red arrow gives you the direction of this flow. And in the southern hemisphere, the Coriolis force operates to the left with respect to the flow direction, 90 degrees to the left. Okay. All right. So the force itself is proportional to the speed. It only exists if there is some motion and something we call F, the Coriolis parameter. The Coriolis parameter is a parameter that is proportional to the sign of the geographical latitude. Nothing at the equator, maximum value at the poles. Okay, we can have a closer look at this.